This video shows a plate girder being tested under bending. The material used in the test is an aluminium alloy. The web has shear stiffness to prevent it from buckling. The loading diagram shows the beam being subjected to 4-point bending. It is also laterally restrained, but close to the ends, leaving a large, laterally unrestrained length. The testing rig is now starting to apply a pair of equal vertical loads to the central third of the beam. As the loading is applied, the beam begins to sag. Under this loading arrangement, the bending moment is uniform in the middle third of the beam. Now, as the beam is loaded, the top half of the cross-section, which is in compression, starts to buckle sideways. However, movement is restricted by the bottom half of the cross-section, which in fact is in tension. The overall effect is to cause the middle of the beam to twist over as well as move sideways. The beam eventually fails by local buckling in the flange, which is induced by the lateral torsional buckling deformation. The graph shows an initial linear relationship between the applied force and the vertical displacement. This corresponds to the bending of the beam. However, when lateral torsional buckling of the beam occurs, the slope of the graph reduces rapidly and plasticity causes ultimate failure, whereby additional local buckling in the top flange is introduced.